Everyone, thanks for signing up and thanks for joining us. Obviously, thank you to our speaker Bernd as well. So just as a bit of background, for those of you that don't know me, my name is Barry Cranford. I'm the founder of the London Java community, and I also run RecWorks, which is a tech recruitment company. So here at RecWorks, we try to find ways that recruitment can be a force for good in the tech industry, beyond just getting people jobs. So it originally came about when I found myself speaking to developers all day, every day, and trying to find interesting things to talk about, and realizing that we were at the heart of this industry, and speaking to developers, CTOs, people relocating into the country and the region, all sorts of people in the same space, and trying to figure out if we could do anything to make, almost to use our position as connectors at the heart of it all, to do good, really. So that's what we've been doing. For the last 12 years, we've been playing, tinkering and experimenting in this space of bringing people together to try and help people learn or connect people with mentors and training and that kind of thing. Just speaking to Bernd there, one of the things we're working on at the moment is an Aspiring Speakers initiative. So if anybody has any interest in speaking at one of our Lightning Talks events, I think I see Dale in the audience, and I know there's a few people out there that have given it a go. Then please do let me know. We can set that up. I also got a few other things for aspiring CTOs and a bunch of other kind of small learning groups. It's all powered by recruitment, so it's all free. The only revenue that we make is from recruiting. So if anyone's looking to hire, then again, look me up on LinkedIn and come and talk to me about it. Anyway, on to tonight. We're going to be talking to Bernd about automating processes in modern hipster architectures. So Bernd's a software developer at heart who's been innovating process automation deployed in highly scalable and agile environments of industry leaders such as T-Mobile, Lufthansa, ING, and Atlassian. He's contributed to various open source workflow engines for more than 15 years, and is the co-founder and chief technologist of Camunda, an open source software company reinventing process automation. He's also the author of Practical Process Automation and co-author of Real Life BPMN. Additionally, he is a regular speaker at conferences around the world and a frequent contributor to several technology publications. He focuses on new process automation paradigms that fit into modern architectures around distributed systems, microservices, domain-driven design, event-driven architecture, and reactive systems. So with that, Bernd, I'll hand over to you.
Thank you, Barry. I just recognized how long the bio is if you read it out loud. We should probably shorten that a bit. But thank you so much. Thank you so much for hosting. Thank you so much for attending. That's actually the much more important part. Just as kind of a housekeeping rule, I have the chat open on another screen, and I try to keep an eye on it. So if you have any urgent questions, feel free to shoot. I'm not sure if I see it immediately, but I try to get into that. And I'm pretty sure, or I will make sure that I have time at the end also for Q&A. So if you have any questions, just let me know. Cool. Yeah, I want to talk about automating processes in modern architecture. I talk about the hipster in a minute. And just to give the context of why this is really important to me to talk about that, and the context we need in order to understand a couple of the arguments here is, I think, very obvious. So if you look at a lot of business models, how they worked 10 years ago, that was during the age of sending postal letters. If you wanted to open a bank account, you basically went to your bank, like here in the town, signed a couple of papers, and then probably a week later you got a letter with some details in it. And that changed to everybody having a smartphone, which basically can receive anything in seconds. And that changes the customer expectations quite a big time, actually, because now people start to expect to get reactions in probably seconds, and they don't really understand why they have to wait overnight for certain things if they can get it much faster at like your competition, for example. And at the same time, we see that basically not all business models, but a lot of business models are in a way digital. They deal with information only. They're not dealing with tangible goods that much anymore. And there was a really good article from Mark Andreessen in 2011, so that's quite a long time ago, and he already predicted that basically because everything is going digital, you can automate everything in software, and that means you can do things very differently, and that will disrupt a lot of businesses basically. And that's what we see today. That's what we are basically summarizing as digital transformation, or these kind of buzzwords we have today. And that changes a lot of parameters on how we build software. And I love that quote actually. And that was last year. I was sitting together with the CIO of a German insurance company for lunch, basically. And we discussed a bit also digital transformation and these kind of things. And he said to me, we also don't know what we need tomorrow. I found that relatively humble because very often people are like, yeah, we know what we have to do. But he really said, no, we have no idea what will be tomorrow. He didn't say no idea, but along the lines. But we know that something will happen, and that change might be very big actually, but we will not see it coming for too long. But when it comes, then we have to be able to move, and then probably very quickly. And my job is to set the organization and the IT infrastructure in shape to support that. And that's exactly the mindset we need nowadays. And that's very much about agility, but not, I mean, we had a big movement around agility, like I would say 10 years back, when we said agile software development, basically. So there we looked at how can we do one software project in a very agile way. But now we're looking at like, how can we organize the whole business in a very agile way to change business processes, to change, to adjust the business model, to try new things, and so on and so forth. So that's actually the need we see from the market. And that's why I love my job, actually. I'm still around with a lot of customers. And if you look at what they are doing, that's a big contrast, actually, to this world where we probably should be. And I mean, the one obvious thing is paper, and it's still everywhere. So much is paper driven, so many processes. COVID actually made this very transparent. When you can't go to whatever, the local bank, as an example, you have to do it via internet. Then you see how much paper is involved in this process still today. But that's the obvious example. What I find so fascinating is actually another example, and that's I see this happening quite similarly in a lot of companies, actually. So let's assume your task is to build a payment service, right? To build a microservice, for example, that should be able to retrieve payments. Because, for example, you have an order fulfillment microservice that wants to use that. Okay, so relatively easy situation. And let's assume the payment service should be able to retrieve or to charge credit cards. Then normally you don't do that yourself, like you don't do all the logic yourself, but you use an existing credit card service somewhere in the internet, probably hosted like Stripe or whatever it is, right? So that's all you want to do. You want to build that payment service. And what's so interesting about that is that it's not super easy. And why is that the case? Because we are now starting really to go into distributed systems. And this is a REST call into the internet. It's not reliable. It might be that the credit card handling service is not available. It might be that the internet connection is not stable. There are a lot of possible issues with that REST call. Now, you have a couple of options there. When you build that and you experience like, I can't reach that other service, the one obvious thing is like you could take it as a hot potato and just throw it over the fence to order fulfillment, say, hey, I can't reach a credit card handling, I can't retrieve payment. What's likely to happen here is actually that the order fulfillment team will not take that and say, hey, this is not our responsibility. We want you to take payment. And if credit card handling is not available, you should probably take care of that. If it takes a minute to retrieve payment, if it takes an hour to retrieve payment, we don't care, but you should be able to handle that. And which makes a lot of sense, especially if you look at microservice thinking. We're coming back to that a bit later, actually. And if we have that situation in mind, what a lot of teams start doing is like, okay, I can't retrieve it like now, but I can't like throw an exception or whatever. So I have to remember that I retry it later on. And then they start to, okay, there I need state, right? So I start to store some kind of state. I say, okay, I have these payments I need to retrieve, and this one did succeed, so it's collected, but the other one is still open. And if I can't call it right away, I keep it in the database, for example, for quite some time. Then I need additional scheduling capabilities in order to regularly look at the table and really retrieve the payment. You might face situations where you have like probably some weird data in the payment request, for example, and this call fails. So you probably have to have some kind of script in order to fix these kind of poison payments and so on and so forth. And if that happened like at least once, somebody will probably approach you and say, like from the business side, hey, we want to have some overview of what's going on in your payment service. We want to have it like a reporting of open payments you're stacking there. And then you're building that on top and so on and so forth. And if you do that for a while, actually, you end up with a lot of code, which is quite complex payment service for a relatively easy requirement, right? And that's what I see happening super, super often. And if we contrast that to business agility earlier on, that's not business agility here, because it's really hard to adjust that service. It's really hard to probably even to understand it if you haven't written it yourself, right? So that's a problem. So what's an alternative? And the one thing I'm talking about today here is also workflow engines. A workflow engine could take a workflow definition or a process definition, if you like to, where you basically sketch a model how such a workflow should look like. And it can be very simple. And I'm doing the example later on. We're doing something live that you can see how it's working. It can be very simple, like, hey, I kick it off. Then for example, I charge the credit card and then I'm done. That's a very simple workflow. I can glue basically some code to the workflow in order to do the real REST call, right? But the advantage I get is that this workflow engine already has all these capabilities of, hey, I can store state, I can have a scheduling, I can retry it, I have reporting on top, I can have operations on top, I can do something if I'm waiting for within that node for too long, and so on and so forth. So there are a lot of advantages of using such a workflow engine here instead of building that yourself. Another example I'm always like doing is batch. So I always take the elevator metaphor for that, right? So probably all know what a batch is. It basically means we're waiting for a lot of items to be processed in like one go. And very often these batches are time controlled. Let's look at an example. And that's what I see, again, in a lot of different companies nowadays. So let's assume you go to your online banking and you want to adjust the transfer limit. So you want to transfer more money per day, for example. And what happens in the background on the side of the bank is to verify, there's a typo, verify the request. The next thing is to adjust the credit limit to really do it, and then you're done. If you implement that using batches, what would happen is that this request is stored in some database. Hey, somebody wants to adjust the transfer limit. Then you have a batch which basically takes all the requests, there are these small boxes, and processes them and write the result in another database, or probably just some column in that database, right? Then all the requests are verified, and then you have another batch taking all the verified requests and really adjust the credit limit, and then you're done, for example. And you can spot that as a consumer very often because of the time controlled batches, you have a delay, you have a latency. So especially in banking, I know that here in Germany, at least, you have a lot of things that happen overnight, and you can see that, right? It's not happening online. But software architecture-wise, I find the much bigger problem here that these batches are basically always looking at one activity or one task of that workflow, right? And it's pretty hard to understand the sequence of batches that are necessary to form the overall business process. It's in that sense, it's orthogonal to the real business process, right? So you basically want to move along here, but you implement all the activities separately. And that, again, for me, is totally not about business agility, because now it's pretty hard to adjust the business process. Sometimes it's really hard to understand the business process, right? I'm talking a bit more about that later on when we, again, talk about microservices. But this is what I see in a lot of companies nowadays. They have all these batches and they don't understand how they are connected anymore. Again, you could use something like a workflow engine instead, and then you really define the business process, like, hey, you verify the request. If it's accepted, you adjust the credit limit. And not only that, run through, you're like much faster without latency, because every request can be processed immediately, but it really implements the real workflow. If something, for example, goes wrong here, you stop here and can see the incident here with all the context. I'll show you that in a minute. And with batches, it's typically like, oh, this one failed, but the whole batch failed. You have no idea which of the item caused it, and how can you restart it? Do I need to clean up some data, and so on and so forth. So I think there's a huge value here, a huge gain you can have for agility. Right, a word of warning, and that's basically about opinionation. Of course, I have my own opinionation. I'm a human being, but I want to make it transparent. I'm obviously kind of the business process or the workflow guy. So I do workflow engines. I do process automation kind of all my life. So Barry asked me in the beginning when I did my first talk, and I think it was 2003 or probably even earlier, and that was already targeting a workflow engine. So I never left the topic. I love it. I find it really exciting, and I contributed to a lot of, or a couple of different open source workflow engines over the past years. I co-founded the company Camunda. We're an open source process automation platform. So I'm obviously, in a way, opinionated. Okay. Just important to know, one word of advertisement. I'm currently writing this book, The Practical Process Automation with O'Reilly. It's in early access, so you can already get some chapters there live, but I have basically all chapters here ready for tech review, doing that with O'Reilly, but I'm still searching for reviewers. So if you're interested and think you can provide some valuable feedback, just shoot me an email and I'm happy to discuss that. If you have any questions which you can't ask today, also feel free to shoot me an email, find me on Twitter, hunt me down there. Happy to discuss everything. Okay, that's the context you probably should know. Let's dive into a quick demo or a quick, I think demo is a better word than live hacking. We can hack everything here if you have questions. So I'm happy to do that, but I'm saving a bit of time actually in order to move forward. So what I have here is basically more or less this example, right? So this example here, I have maybe the other slide is better. I have the payment service and I have a credit card handling service here. So what I can see here is that I have I called it Stripe Fake service, and I have the payment service. Whenever and this is kind of now the order fulfillment service, like my REST client, this can talk to the payment service, which then will charge the credit card, right? So if I hit this, you will see it arrives here, then here, okay? So far, so fancy. We're looking into the code behind that in a minute. Now, oh no, let's look at the code now. Why not? So the code is relatively simple. I'm using Spring Boot here. I can't really do a show of hands here. I mean, I can, but I think it doesn't work that well. So let's assume most of you probably do Spring Boot nowadays. I have my REST controller. I implemented the put method in order to retrieve the payment. Then I do a system out print line because that's what you do. Don't adopt my best practices here. And then I do the real business logic, which is charging the credit card, which basically means I do, using the REST template from String, I do a post for the Stripe URL, send over a request, get back a response, and probably extract some data from it. That's it, right? That's the whole version 1 example. You see, pretty easy, and probably most of you have done something like that in the past. What I can do now to make that a bit more interesting here is I can let the this service to behave slow, right? So this will now take longer than 0 seconds to retrieve a payment. What happens? I mean, that's pretty obvious. Don't have the time. No, it should be slow. Hang on. Slow. Service is not slow. Sorry. So now it's slow. It takes longer, right? What happens is not so much a surprise. Basically, this is calling that service. That service is blocked. The thread is blocked, waiting for response from that service. And that means everybody is currently blocked and waiting. That's a pretty bad situation to be in. You should definitely avoid that. I'm not talking about that today, just as a hint. Patterns like circuit breakers, for example, service meshes are taking care of that. So I have a circuit breaker actually in version 2. Version 2 does something here. It still takes long, but what we can see is you get an exception from the circuit breaker. That's basically like the circuit breaker in your house. Something is weird with the electricity. It switches it off, right? And that means I get an error here relatively fast. I'm not blocked waiting for something to respond. So that's what you should do actually, at least. But now we can see basically 2 problems here immediately. The first is like, hot potato. I get back the error. That's what we wanted to avoid. The order fulfillment should say retrieve payment. If this doesn't work, it's not the problem of this client. The second problem, if you think about it, is, as you can see, we do a charge on the credit card, but we will probably not send the order, right? So we even have a really big inconsistency here, which will probably not make our customer very happy, okay? So that's a problem we need to solve. And that's where we start to use the workflow engine, in this case, Camunda. I use the Spring Boot starter, added it to my dependencies. Then I can immediately inject the process engine here. Then I can create a workflow, and you can definitely model workflows graphically if you like. So there's a graphical modeler. Let's probably look at that in a minute. But I always like to start with the basically with a bit of Java code, because you can also define these process definitions in Java code. And my experience in the past was that a lot of developers are like, they fear some hidden magic behind graphical modeling, because there can be something you don't see, right? And that's not the case in code. So that's it. You don't need more. You say, I want to have an executable process. We use BPMN, that's an ISO standard to define these executable processes. I start here, I end here. In between, there's a so-called service task. There's one task where I do something. And now I can attach logic to it. And as I'm using Spring here, the easiest thing I can do is attach a Spring Bean, or refer to a Spring Bean, which is defined here. And that just implements one method, which is called when the process instance moves or walks through that one service task. And the code I have in here is exactly the same as before. to say added the circuit breaker. Don't want to talk about circuit breaking too much today. So pretty easy. And what do I get from that? Now I have really the workflow engine at play. And that means, I mean, a couple of things we might see later on, like versioning of these kind of workflow models, which are important in other situations than this. But especially here, I could do something like, hey, if this fails, I want to do a retry, and I want to define a time cycle for that. In this case, retry it 3 times with a delay of period time 1 minute. That's an ISO standard in which that is defined. Okay, and then the workflow engine takes care of that. I don't have to write any code in order to do that. And looking at that, that's version 3. Is again, charting takes too long. Circuit breaker cuts the connection. But now you can see 2 things, or probably even 3. One is we don't get a 500 anymore. We get a 202. We don't get a 200. HTTP 200 means, hey, we're done. We get a 202, which basically means, yeah, I got your request. I will do it. I will talk to you back later on, right? That's exactly what we want to have here. The second thing, if I talk for long enough, is you will see the retrying going on. So we have to wait for a minute. So I'm not waiting. I keep talking, but we probably see it passing by in the background. So if I open up a browser, what we can do is we can look at the third thing here. Workflow engines normally come with a UI where you can look into the state of all my processes, potential problems, and so on and so forth. And I normally like doing that because for a lot of people, this immediately makes them understand what a workflow engine is. Now that was the retry. Because now I can look into, hey, what's going on in my payment V3? And if I look at that, I will see that there is currently 1 instance just hanging around here. If I get the next retry, what you will see is that it creates an incident because that was then the last retry, and an operator needs to look into that and just do something, right? But you can see that it's currently waiting there. And if I will probably start a couple of others, I can see that there are multiple instances waiting there. I see something in the chat about Hystrix is no longer active in development. That's totally true. I didn't add the comment here. Yes, of course, I wouldn't use Hystrix anymore. Use, for example, Resilience for Change. That makes a lot of sense. That's what I meant. I don't want to talk about circuit breaker too much. But you're totally right. Totally right. Hystrix is nothing you should use in a new project. Awesome. Let's restart that. I'm still waiting for that one that should actually expire here. So now I have the first one, which is out of retry. So you have an incident. You can even you can look into that. You can see all the data. That's what I meant with context. Now you can understand, okay, it's here. What's the problem? That was a stack trace, timed out, no fallback. So as soon as that, for example, gets back to normal, you can probably, as an operator, say, okay, that was a hiccup with the service. I know that. I can retry it. And by the way, you can do everything here also as a batch. So if that's not 1 instance, but 100K instances, you can also do that. And if we go back, we should see that one already healed itself. The other one is already retrying. The next one is still waiting for the minute to pass. Yeah. So that's a very different behavior, right? Cool. Just adding 1 or 2 notes here, of course. I mean, I love starting with that super simple process, because a lot of people, when I say process automation, think of like huge end-to-end business processes, but the value can start with these simple processes. So the basic value here is that you have the state, you have persistent state, and you have that scheduling component, and everything else is around that, like the operations tool, and so on and so forth. Right? But of course, most of the processes are bigger. But if you imagine retrieving payments, that starts to get more complicated anyway. Like you probably say, oh, I don't want to charge the credit card immediately, but before that, I want to get, I want to look at the customer account. If he has credit, then we use that before, right? So that could be something. And that's, by the way, the graphical modeler now. So there you can do whatever you want to. And this is another interesting problem here starting to merge, like, okay, now I have 2 remote calls. What if the charging of the credit card fails? Now I already deducted some customer credit. That's probably pretty bad, right? That's inconsistent again. So you might even want to think about undoing these kind of things, like, okay, the credit card charging failed. So you need to, that's a rewind symbol. You need to undo whatever was already done. And then you can define these undo or compensating tasks for other tasks in the process model. And that's what a workflow engine can automatically do for you. So there are a lot of these kind of things where you can do. So let's briefly or quickly move on here. I just wanted that you have an idea of what a workflow engine is. And I'm happy to go into all details you might be interested later on, because there's some, I think it's a more in-depth Camunda or BPM question. I would like to table that for a bit later. So just as kind of a wrap up, if you have a workflow engine, it basically can orchestrate things. Orchestration means coordination in a way. And you can orchestrate a lot of different things. Like, for example, you can orchestrate decisions, like rule engines or DMN engines. Camunda has also something in there. You can orchestrate microservices. You can orchestrate RPA, stands for robotic process automation. So you can automate these so-called bots that can steer graphical user interfaces of applications that don't have an API, right? That you can't call via an API. So you need to steer their user interface. That's what RPA is for. So you can orchestrate them or serverless functions or whatever code you have. Cool. Why is that so interesting? Because you have to wait for humans, for systems to become available, for asynchronous responses, and so on and so forth, right? So a lot of reasons to wait, and the workflow engine helps you with that because it can persist state. Cool. If you wonder, and I'm showing that slide, or I like showing that slide because a lot of people wonder, like, okay, but what I'm doing with that, or what's the typical use case? And there are so many. So that's a slide from our customer success management where they look at different industries and what they do with the platform. And you see that it's sometimes pretty core, like trading or fraud detection or order fulfillment, sometimes order fulfillment, and so on and so forth. Underwriting, claim settlement, customer onboarding. So all these kind of use cases. Just to sparkling imagination. Camunda is an open source tool. Try it out yourself, camunda.com. I think that's the most important part here. What I tend to add, if people already know Camunda, very often they are not aware of our size. So we're reasonably big and we're growing quite fast at the moment. So it's not some weird project I invented and nobody uses. So we're long left that stage. But let's talk a bit about microservices. And I want to connect these two worlds actually. And that's what I'm discussing super often recently. So we have process automation on the one hand, and we have these microservices trend at the other. And I don't want to define microservices in detail. For me, the important thing is we try to unbundle like monolithic software into independent components like microservices or services or probably functions or whatever. And for me, the important thing is that you have a lot of autonomy in the teams caring about a microservice. So one team can make all changes in one microservices. You don't need 2 teams for that. You don't need the database team. It's like one team. And they're deploying on one hardware is probably not the right word anymore, container, whatever it is, but they're not sharing an application server between like two teams, or they're not sharing a database either. So they have their own environment. They're really autonomous. They can, and the idea is that they can make changes without discussing that with a myriad of people. They can move fast, and this supports the business agility we talked about in the beginning. That's why we're doing that, because then we're faster in adopting changes because we don't need that many people on the table. That's microservices. If you don't like the word microservice, for me, the important thing is it's really about basically APIs and components. It might be microservices, might be external services, might be functions, might be your existing standard software or legacy software even that has an API. And now you need to connect these in order to get a useful business process out of that. So normally no not trivial function is implemented in one of these boxes in its entirety. Normally you need to connect a couple of these together. And that's why I use the Hipster currently. And let me explain that. So my observation was that the Hipster works on a marketing level very well. So I use the word also sometimes in the title, like here. And I like to use a picture, but what I don't want is that you think I think that you get the impression that I think, well, that's a complex sentence, that I don't think, event-driven or reactive or all these kind of trends are nonsense. That's definitely not the case. There is a big value actually in these modern architectures, and I use the reactive manifestor normally to anchor that. So for example, that manifestor says, if you want to have a responsive application, in order to be responsive, it has to be resilient. And resilient means that components can fail without the whole system to failing. So probably some component is not working, but the rest is doing well, right? And it can be resilient for coping with that failure. It can be elastic. So if you have many more customers storming at you, you survive that. And normally that's achieved by going message driven. And if you look further in like modern architectures, very often that's even going one step further, saying, hey, we have to go event driven. And I think there is a huge value in event driven architecture. And I probably don't go into that too much today, but I really think there are super good use cases for that. But the problem I see at the moment is that a lot of products now running for event-driven architecture, like this is the silver bullet now. Let's do that for everything, and that doesn't work. There's a big risk connected to that. And let me do an example in order to make that point. Assume you want to do some order fulfillment. And that could be that you have a couple of microservices, like the checkout microservice, where basically the customer checks out his order, payment microservice, we talked about that, inventory, where you want to know how much things are in stock and where, and shipping, right? So these are microservices you have. Now, if you go event-driven, what you could do is that all these microservices basically publish some event on normally some central event bus, and they don't know what happened with that event. They don't care. They just publish that event. It's a domain information, like, hey, somebody placed an order. Okay, that's interesting. And then you could build, like, for example, another service that subscribes to certain events, like, for example, a notification service that subscribes to a couple of events in order to send notifications to the customer. Like, hey, here's your email here's an email, we received your order. We received your payment. The goods are on the way. This is your tracking number or whatever. This is actually a very, very nice example of event-driven, because that makes everything so much easier. You basically have the responsibilities to send notification and all the code in one place. And you don't have to think about, oh, when should I send that email? How do I send emails in the payment service? Payment don't have to care about these notifications at all. Okay, so that's a huge advantage here. Now, the problem starts when you apply that for everything. And what I see very often are so-called event chains. So if you can, or basically you can also implement the business process by events only. So for example, checkout could say, order placed. And then the payment microservice could say, okay, I subscribe to that event. I'm interested in that, and know then that I have to retrieve payment. And then I receive the payment. So inventory could say, oh, if payment was retrieved, I need to get the goods from stock, right? Then this happened, and then shipment, and so on and so forth. And this chain of events implement the business process on the right-hand side. Okay, so it will definitely work. The system will work. But my big problem with that is that you can't see it anymore. It's emergent behavior. It's just emerging during runtime. You don't have a single place in the code base where you can look at in order to understand it. You normally have to really observe like the running system in order to get at least an idea of what's happening here, right? And that's a big problem. Martin Fowler blogged about that also already in 2017. So they also did a couple of these projects, and he wrote about like the danger is that it's very easy to make nicely decoupled systems with event notification without realizing that you're losing sight of a larger scale flow, and thus set yourself up for trouble in future years. And that pretty much captures my gut feeling as well, right? And that's what I saw with a couple of projects. I like this slide very much from Phil at QCon New York in 2019. He worked at Meetup at that time. And he said, okay, we were suffering from pinball machine architecture. And that's kind of referring to exactly this. I made my own slide for that. So it basically means you throw in like the first event, and then this like dong, 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 somehow bounces through the system, and you have no idea why and how, right? And that's a big, I love the animation. And that's a big problem actually. So you typically recognize that by the amount of times people ask like, how did that happen? That can't happen in our system. We didn't implement for that, right? That's a problem. That's a huge problem. And it goes further actually when you want to change things. So far, we talked only about, I don't understand what's going on. But now let's assume you want to change things. And that's again about business agility. We talked in the beginning. We want to adjust the business process because the world has changed. And for example, we want to fetch the item from the warehouse before it's even paid because we need to do the same day delivery, for example. We need to be faster, right? If you want to do that on the left-hand side, what you need to do, and you can think about that as like, okay, payment no longer needs to react to order placed, but inventory does, and payment needs to listen probably to goods fetched, and so on and so forth, right? So you have to do a lot of changes here in the subscription. Basically, you have to update all the 3 services here in order to cope with that. And not only you have to update 3 services, which is already one problem, but you also have to coordinate their deployment because you need to know, I mean, as soon as you update that one, you also need to update this one, and you need to know for every order in which version of that flow it's basically going around, because it's important in inventory to know if it's already paid or not. So that's a really complex problem, and it's totally not in line with the microservices idea of autonomy, right? So I see this as a huge problem, actually. It's as a huge risk you're running into if you're doing these choreographies too much. Yeah, these event flows, they're called choreography. I mean, it's probably could do an own talk about the definition of choreography, but that's the essence of it. And if you listen into talks that talk about choreography for longer, normally they use this metaphor, like a dance. And you have these dancers, and they know the rules, they know the choreography, so they can dance. You can add another one, another dancer, and if she or he knows the rules, everything is good, right? And it will be beautiful. And that's not exactly what I see in real life. It's kind of chaotic in a way. It's hard to manage, hard to understand what's really going on, right? And that's a big problem, actually. And I see that, or I saw that already happening at many places now. And some of you are even talking about that publicly. And one of the reasons why this is still happening so often, and that's my hypothesis. I'm happy to discuss. My hypothesis is like, okay, it's in this architecture, it's easy to emit events. So you add your first service, you emit events, and you add your second service, probably reacting to a couple of events and emitting its own. And then you have another service, which again reacts to events, probably emitting its own, and so on and so forth. Adding things is easy, right? And then you never, or normally don't have to change the other services because the events are already there. But what it's harder to understand is that this comes at the expense that this service, this system is really hard to change. If you want to remove an event, if you need to change the sequence in a flow, as we just did, it's really, really hard. So from my perspective, this is kind of kind of a shorter initial time to value, especially at startups. I saw that a couple of times. You want to go fast, so you go with that choreography, but you need to be aware that this is kind of a technical debt, that this can backfire as soon as you really need to update certain flows here. That's something you should be aware. For me, there is even one more thing which is really weird about that example, is that the order fulfillment, the core capability of companies like, okay, Amazon, you could discuss that, but how they started, or Zalando, or whatever it is, as order fulfillment. It's weird that they don't have one microservice or one team which is really responsible for doing that. I think that's much more natural to have. And as soon as you have that, you probably still have events flowing around. So I could imagine that checkout still sends an event, say, hey, order placed. I don't know what happens. I don't care. Here it is. Then the order fulfillment microservice takes over, but then it's so the order fulfillment service is responsible, or the team doing it is responsible for retrieving the payment on time. So it's not about payment is responsible for reacting, but it's really about order being responsible for, hey, payment, now retrieve payment for me, please. And then you wait for the result, and inventory and shipment in the same way. And that's a different way to think about it. And that's what's orchestration is about, for me at least. Orchestration means I coordinate somebody else, like the payment service. And that can happen from within the order service. That's totally fine, right? But it's orchestration. It can still be messaging. Super often I have the discussion like, you're saying orchestration, so you want to do REST there? No, that's not what I'm saying. You can do messaging, you can do asynchronous, you can still build your reactive and responsive application. No worries. You can use Kafka there. All good. It's simply about the responsibilities. Payment responsible to make sure it retrieves payment at the right time, or is order fulfillment responsible to make sure that payment is retrieved at the right time. And because we're using distributed systems here, or probably messaging, you have to wait. And that's why this orchestration might require state pretty quickly, as we saw at the very beginning already with payment. And this is why it makes so much sense to connect orchestration to a workflow end, right? Because then you can wait. And then you can express this orchestration logic also in a workflow, like in BPMN, for example. You could say something like, hey, now retrieve the payment, and basically that sends over a message to the payment service. And then you go in waiting mode and say, I wait now for payment received. And then you move on. So you're not adding any details of payment, but you're basically adding business logic of the order microservice. Right. And now it's easy to change that flow. You first of all, you understand it, and you can even change it. And the like workflow engines version, the process definition, the model. So you can even have orders flowing through that version still, and they keep flowing in that version, and new versions starting in that. And that's much more, yeah, it allows you to survive that situation in a way. Okay. Right. And if you're deeper in microservices, I find this one of the most important thoughts. These processes are domain logic, right? They live inside of that microservices boundary, and it's nothing central. It's not that you have this BPM thing over there, which is a weirdo, but you basically have orchestration logic within a microservice. And because it's long running, you leverage a workflow engine for that. And probably the payment service has its own workflow, as we saw early on, and probably inventory as well. I don't know from the outside. I don't need to. They have an API. Cool. So that was a quick walk through the, let's say, more reactive event-driven microservices stuff. So the point I'm trying to make is like a workflow engine can execute long-running processes. Long-running basically means I need to wait for things like messages, REST services to become available, humans, RPA bots, whatever it is. Whenever I need to wait, it's long-running. That means I have to store state, I have scheduling, I need operations, and so on and so forth. You don't want to build that yourself. If you add the visibility component of visual workflows like BPMN, what we saw, that even allows you to talk about that with business stakeholders. Your operations people can understand what's going on, understand context. That's, from my perspective, super important for business agility. Event-driven choreography, so the hipster thingy, it's not a magic cure. I think there's a big value in it, but you have to adopt it with care, and you have to balance it with orchestration, because that helps to avoid a lot of the chaos, and it can be handled within one service. It's nothing central, and it also doesn't mean synchronous communication. Nice. If you want to see a bit more code, and by the way, the code I showed here is also available on GitHub. So if you go to my GitHub page, and there is one repository, and that's called Flowing Retail. So that's my retail example. And there you find the REST folder. That's the example we already looked at today. So if we go at REST, you will see the Java example doing exactly that. And if you want to look more at the like event-driven thing, you can go to Kafka, to the Kafka folder, and it's Kafka here, but it could be RabbitMQ as well. So it's not tied to technology, right? And then you get like all the microservices I had on the slide communicating with each other. So you can really play around with that in a choreographed version, in an orchestrated version. If you have any problems, any questions, let me know. But for me, it's always important also to have the ideas I have on the slide also in kind of code. Otherwise, it's I don't know, it's not real on the slide. Okay, we can do a couple of things now. So that was kind of the the content I had. I promised cloud in the abstract. So what I could do is I could show you an example with a managed workflow engine in the cloud. So basically Camunda Cloud in that case, if that's interesting to you. I quickly have a look at the chat for one or two questions we had in the meantime. And you can definitely make up your mind if you have more questions for me that you want to shoot, okay? Okay, we have an excellent question, actually, about sub-processes and microservices boundaries. So let me go to this slide. There's one thing in BPMN, just to get everybody on the same page. In BPMN, there are two things available, which are interesting here. So one is called an embedded subprocess, and let's expand that. Thank you. We have an awesome UI in the model. And a subprocess, an embedded one, it's just part of the process. It's an additional scope. And why is that valuable? Because then you can start attaching, like, for example, timers in here, and can say, wherever I am within that process, I don't care where. If that takes too long, for example, I skip doing that and do something else, right? So that's a sub-process in BPMN. BPMN knows another thing that's called a call activity. And the call activity is basically means I invoke another BPMN process defined somewhere else. So I say, okay, this is my child process, and that's called here. So whenever the process instance enters that task, it basically starts this one, and whenever this one is really finished, I move on there. Now, you could use that here, where you say, hey, payment is kind of a call activity, and here's the payment process. But that would make an assumption, and the assumption is like all the microservices are operated on one workflow engine, and basically you use the BPMN call activity as kind of an API technology to call another microservice. And while this is technically feasible, I wouldn't do that. If you go for microservices, if you have the different boundaries, I would apply the workflow engine only within one boundary. That means you can use a call activity, but the called process must be within the same context. And you use that for whatever, like having a method call in your class where you try to structure the code that it's easier to read. You can do that, but you can't leave the boundary. That's my typical advice for microservice architectures. Everything else needs a longer discussion, because that's a really an exceptional situation, which you can do, but you should have a good reason for that. Okay, somebody said looks like IBM doors. I'm not sure when exactly that was in the conversation. My guess, hopefully, probably here when I showed Eclipse, because Eclipse is kind of the ugliest piece here, but I don't know. If there are no more questions, and feel free to shoot them, I will quickly do a quick from scratch example, not using Camunda BPM for a second. And just to give you that context, what I use is Camunda. Camunda.com, open source, Apache license, Spring Boot Starter if you like to. Deployed on-prem. So if you use Spring Boot Starter, it's part of your application, right? If you look at the homepage, what you can see is that we have two different products. So Camunda BPM is the one you saw, and that's kind of the flagship. That's kind of the what we make money with. And then we have Camunda Cloud, and Camunda Cloud is kind of the new thing. We're in a public beta at the moment, so it's a managed workflow engine. So if I go to Cloud Console, let's quickly do that. Then I can create a new cluster. Let's say I call that London. Let's do a development cluster. Yeah, why not? Region Europe is nice. So let's do that. What it basically does is now starts up a complete setup with a workflow engine, with the operations tool, and so on and so forth. I already get a couple of credentials and endpoints. And now I can connect to that from, for example, my Java application, because let's do a hello world. in order to showcase that. Hello, computer. So I'm creating a process, like a very simple one, like a service task saying hello London, and right, that should be it. The type is, call it sysout. That's already something which is executable. Diagram 1 is the perfect name for it, so we definitely need to keep that. I can deploy it, and I can deploy to Camunda Cloud right away. I create a new client, which basically means credentials for the clients. And let's say that's the modeler. I'm probably not doing different clients here. Hang on. Come on. So that's the address. I only need the cluster ID. Sorry, I copied too much. The client ID. And the client secret. I could also copy it above, but I like this actually. Remember that, please. Yes. Then I can deploy it. And what I did is I deployed the workflow to my cloud instance. Let's quickly look at that. So I can look at the operations tool. Oh, thank you, DNS. Let's wait for that to happen, hopefully in a second. And I could actually already deploy it. I can also, I guess, kick off a new process instance. Yes. And now what happens is basically the workflow engine started the process instance and it's currently waiting for it. And what I can't do in that cloud scenario is basically attach Java code to it. And we're advising against that scenario in most architectures anyway, actually. So what you can do instead is you can basically subscribe to the workflow engine and say, oh, I could do sysout. And that's what I can do here in my Java code. And again, I use Spring Boot. So I use the Spring integration where I basically say, hey, I want to have CB enabled. I need to configure my endpoint for, again, these credentials. Let's copy them. So we need the cluster ID, which is this one. We need the client ID. And if you do it right, you have own credentials for different things, right? I'm saving a bit of time here. So doing this, then I could say like, hey, I can handle, how did we call it, sysout? Forgot. Yeah, sysout, I can do sysout. So let's say sysout, hello London, from only good with typos, and let's start that. There's a question, if you have multiple of this process, is there a central station where you manage them, or is always over Eclipse? So Eclipse is not part of any of it. I mean, I'm currently, I have a DNS problem here, obviously. That's weird. Or did I copy the wrong thing? Hang on. Let's cluster ID. Let's copy that for making sure I'm not messing it up. Cluster ID. Okay. Client ID. Did I mess it up? That looks good. And then probably the cluster ID was, no. Eclipse is not part of any of the tooling. So what I basically have is these process models there, in this case, are part of the of your project. If it's a Java project, they're probably living in source main resources somewhere in Git. So Eclipse, I'm just using Eclipse because I'm having gray hair since started Java like 10 years or 15 years back. you can use whatever you want. Eclipse is not part of that. The modeler I'm showing here, it's a standalone application that you can download and basically uses JavaScript capabilities in there. So you could have the same experience even like in the web, if you like. So we have, for example, also have our own web tooling where you can model and discuss models collaboratively in the web. It uses the same thing. Okay, so Eclipse is not part of any of this. So now it worked, like it said, hello London. And if I start the next one, right, you will see that it again says hello London, and I give it a last try on the console. Yeah, that looks better. Sometimes DNS takes a moment to get it. So what I can see is that I deployed that process with the handy name because I didn't change the ID. It says hello London. I have these 2 versions which are already finished, and you can look into all of that. You can look into like what's going on and so on and so forth. Same thing as we saw earlier on, but in the cloud. Where's a good place to start when first trying workflow engines? Good question. Very good question. So, I mean, the one thing, but I'm again biased, don't forget that. What I can recommend is that book, which I want to have in exact that position. I'm currently writing it, so it's kind of probably not ready, but especially if you're starting, happy if you shoot me an email. I can probably give you access to the current draft because I'm also like feedback, especially from people starting with the whole thing, if that's a good resource to start. So that's the one thing. If you're reading kind of person, if you're more the doing kind of person, I would say just go to the Get Started guides. I mean, if you don't want to use Camunda, if you use something else, go to their Get Started guides. But if you don't care, if you just want to learn about it, I would just say go here, do the evaluation later on, and we have a couple of Get Started guides in order to walk you through the core thing, and that normally helps a lot to understand the basics. There are too many, it's also a question about common mistakes, but there are actually too many common mistakes to say, okay, that's the top one reason. Because if you remember that slide earlier on, there's so many different use cases, so many different scenarios a workflow engine can be used in, so many different architectures, that there are a ton of different possibilities where you do whatever mistake. What might be interesting, there are best practices. So if you go for Camunda, we have the Camunda best practices. I've documented, basically that's the experience from the whole consulting assignments we did over the last 10 years, extracted to certain best practices. For example, if it comes to testing, how do I test processes? I haven't talked about that, but we can do unit testing very easy. How can I do that? And so on and so forth. So there's a lot. But I would recommend get started first, do your first steps. We have a good forum to ask questions if you want to dive deeper into that. Are there any more questions at this moment? One, two, three, no? Does look like that. Thank you very much for attending. I hope that was interesting and enjoyable. I wish you a super nice evening and see you sometime, somewhere again. Bye, guys.